Okay, so let's start today class. Today we are going to discuss this numerical based on the auto transformer. Okay, we already described their operating principle of a step-down auto transformer in the previous class. So just to consider today we have an example based on the auto transformer. Now we can just find out the various component. That means whatever we drive for how power transfer in auto transformer, some part of the power by the transformation, that is transformer action, or some part of the power by the directly conduction method. Okay, so just we try to find out here if we consider one example based on the auto transformer. So just we try to first of all share the screen and then we will continue our discussion and some specific parameters. First of all, note down whatever given in your problem. Okay, and just concentrate how you can find out the unknown parameters. Is not. So just try to see here. Today we consider here, that means topics is suppose that. So problem based on the auto transformer. Okay. Problem based on the auto transformer. Auto transformer. Forward. Yeah. So suppose if you consider one example, that means given problem, that means a two winding transformer parameters given to you. If that two winding transformer if connected as an auto transformer, then just find out the various component of the auto transformer. It is not. So just we consider a 20 kVA 20 kVA two winding transformer is to be used 20 kVA 2300 volt by 2030 volt 30 volt two winding transformer two winding transformer former is to be used as an auto transformer is to be used as an auto transformer auto transformer transformer which constant source voltage of 2300 which constant source voltage constant source voltage 2300 volt 2300 volt at full load of unity power factor at full load of unity power factor unity power factor calculate the power output calculate the power output power transform power transform and and power conducted if the efficiency of the two winding transformer at if the efficiency of the two winding transformer of the two winding transformer two winding transformer at 0.6 power factor at 0.6 power factor is 96% is 96% find the auto transformer efficiency at the same power factor. Find the auto transformer efficiency efficiency at the same power factor okay. So this is problem given to you, that means in data provided of two winding transformer that is reconnected as an auto transformer. Is not two winding transformer is reconnected as an auto transformer. So source voltage is same as the previous one, that is whatever the two winding voltage source high voltage side 2300 volt is again here constant source voltage in auto transformer also, that means 2300 volt at full load of unity power factor. So calculate the whatever the power output rating of the auto transformer. This power rating is given to you two winding transformer. Okay. So in reconnect as an auto transformer, just find out the power rating of the auto transformer, whatever the power transformed by the transformer action and whatever the power transformed by the direct conduction method. Okay. And next, if the efficiency of the two winding transformer is given as 0.6 power factor is 96%, then find the auto transformer efficiency at the same power factor, that means 0.6. Okay. So this transformer we can connect as an auto transformer by the two different way of connection. Okay, so just we go discuss by one how we can just connect these two winding transformer as an auto transformer. So just try to solve this problem particularly given to you. So that means the connection of the source voltage is your fixed 2300 volt, and how you connect the LV winding, that means 2030 volt, is not. So this is consists of two way of the connection. Okay, so just try to consider one by one. Suppose that if you consider figure number one, that means figure number one. Okay, so in figure number one, suppose that this is your 2300 volt constant source voltage. Okay, and you maybe see that the this is your just like as a step up auto transformer. If you consider from this winding A to C, and the primary winding as B to C. Okay, so this is an auto step up transformer. So primary voltage is your 2300 volt, and second side voltage is your, you consider 2530 volt. In this way, that means secondary side winding connection. Suppose that if you consider polarity as this one is a positive and this one is negative, so the this voltage is the summation of the two voltage. That means 2300 volt and 230 volt. If you take the reverse of this connection, that means E2 EMF, EMF in of the secondary coil, that means this one is your positive and this one is your negative. Okay, so you maybe take the this voltage is your how much difference between the 2300 volt and 230 volt. Okay, so just we try to see one by one. Suppose that if you consider this polarity of the connection, so first we try to find out the two winding transformer LV and HV side current. What is the current value of the LV and HV side? Is not. So the rated current on the HV and LV winding are respectively in two winding transformers. Just find out how you can find out. That means KVA rating divided by voltage of the LV side or HV side respectively. That is nothing but your current of the LV and HV side. So just find out here the rated current on the HV and LV winding respectively. So the current rating, current the rated current, the rated current on HV and LV winding are respectively uh, respectively so IH equal to how much? That means KVA rating divided by HV side voltage rating, is it not? So HV side current is represented by I suffix H. That means I suffix H equal to KVA rating divided by high voltage side voltage rating. So KVA rating is how much? 20 KVA. So 20 into 1000, that means 20,000 divided by HV side voltage, that is 2300 volt. Is it not? Is equal to how much? Divide 8.69 ampere. 8.69 ampere. Is it not? and IL equal to how much? KVA rating divided by voltage rating of the low voltage side, is it not? So KVA rating is your same 20,000. That means 20,000 divided by voltage on the LV side. That means 230 volt. So it becomes nothing but 86.9 ampere. No, that means low voltage one side current. Not. So if you consider the LV and HV winding connection, they are similar like to this one. That means HV side connection is your how much? 2300 volt, and current is flowing this winding is nothing but 8.69 ampere. That means this one is positive and this one is negative polarity. So current is flowing from higher potential to lower potential. And if the EMF direction you may be so that E1 is represented by E1 opposite to the supply voltage. You know. So if you connect secondary coil in such a manner that the polarity of the E2 secondary side is coincide with the B, small b. Okay. So this EMF is already given to you 230 volt. And how much current flowing? 86.9 ampere. So current flowing in this direction is 86.9. So what is the current at this point? Can we find out? Suppose that 8.6 ampere is flowing in this direction and 86.9 is flowing in this direction. So how was the current taken from the supplier? That means the summation of the two current is not. If you apply the KVL at this point B, then you will get the supply current value, that is nothing the summation of the two current. Okay. So if you consider this one as figure 1, okay, figure 1 we consider as figure A, this one. Okay. So the output voltage is how much? The output voltage is summation of these two voltage, is it not? That means from minus to plus and again minus to plus. So this is the series adding of the two voltage source. Okay, that means 230 volt plus 230 volt. So the output voltage is nothing but the output voltage is 2300 plus 230 volt. That means how much? 2530 volt, is it not? So 2300 volt means you may be written in the equation form, that is better. So right here, output voltage rating is your nothing but 2300 plus 230 volt equal to 2530 volt, is it not? So this is your output voltage of the auto transformer if you connect is in this way. Okay. So because the two windings are in series adding, because of the two winding are in series adding, series adding. Okay. So rated current of 86.9 ampere in the LV winding requires by transformer action. So the transformer action takes place at the between the winding BC and AB, is not. So rated current of 86.9 ampere in the LV winding LV winding requires by transformer action requires by transformer action a rated current of 8.6 ampere in the rated current of 8.6 ampere of 8.6 ampere in the 2300 volt 2300 volt winding acting as the primary acting as the primary KCL at point B. If you apply KCL at point B, so apply KCL at point B gives the line current from the supply line to gives the line current from the supply line to be equal to summation of this current plus this current, is not. That means equal to 86.9 plus 8.69 equal to 95.59, is not. 95.59 ampere. So this is your supply current or line current that is drawn from the supply source. Okay. So now what is the rating of the auto transformer? What is the rating of the auto transformer? That means whatever the total output voltage appear across the winding, is winding AB, oh sorry, AC, or current flowing through this winding. Okay. So this one may be equal to the rating of auto transformer. So auto transformer के V rating is auto transformer के V rating is KVA rating is equal to either may be written as total voltage appears in the output terminal, that means AB, that is 2530 volt, into whatever the current flowing this winding, that means 86.9. Okay, or this voltage 2300 volt into whatever the current flowing through this one. So current flowing taken from the supply side. So either you may take this side of voltage and current ampere rating, or maybe along the outside output terminal. So output terminal is your nothing but two voltage into current. KVA rating is nothing but voltage into current. Okay. So if you consider output side voltage terminal or current, then you just multiply by the output voltage and current divided by 1000, that is converted into kilo. Okay. So 2500 530 into current flowing is how much? 86.9. 86.9 divided by 1000, or maybe equal to if you take and consider along supply side, that means total voltage, that means 2300 volt supply voltage into supply current, that is 95.59. So it's one equal to how much? 2300 volt, 2300 volt into current of the supply side is your 95.59 divided by 1000. 1000 is divided for the conversion in kilo, is not? So this one is nothing but 220 kVA. Okay, kVA. So kVA rating is 2000 kilovolt. Out of 220 kilovolt, how much the power transfer by the transformer action and how much power transfer by the direct conduction method? So that we have to find out here. Okay. So the power output at full load of unity power factor is nothing but 220 kilowatt. So the output, the power output at full load of unity power factor, full load of unity power factor is equal to 220 kilowatt. Is it not? 220 kilowatt. Here winding BC. That means here which winding take place the transformer action? Winding BC and AB take as the secondary. Here winding BC act as the primary and AB is your secondary winding. Okay. So here winding BC act as the primary, winding BC acts as primary and winding AB as the secondary and winding AB as the secondary. And so transformer action take place between the winding AB and BC and AB. So KV transform, that means so KVA transform transformer action is equal to how much? That means voltage across the winding AB into whatever the current flowing through the winding AB divided by 1000, is not. So voltage appear across the winding AB is your 230 volt into current flowing this winding 86.9 ampere. If you divide by 1000, then convert it into kVA. Okay, or you may be say that from the input side, that means 230 volt, 2300 volt. 2300 into current flowing is 8.69 ampere through this winding BC. 8.69 divided by 1000. That means nothing but 20 kVA. So out of 220 kVA, only 20 kVA transfer by the transformer action and remaining by the conduction method. So we will find the power, that means power transformed equal to 20 kilowatt and in kVA kilowatt. So and power transformed equal to maximum, that means unity power for the unity power factor, that means equal to 20 kilowatt, is not 20 kilowatt. So remaining power transferred by the directly conduction method. So kVA conducted equal to, so kVA conducted equal to 220 minus, subtract the power transformed by the transformer action, that is nothing but 20 kVA. So remaining is your 200 kVA power transformed by the conduction method. Okay. So power conducted equal to 200 kilowatt, 200 power factor. So power conducted equal to 200 kilowatt. Equal to 200 kilowatt. Okay. So here you can say that how 20 kVA two-winding transformer is capable of handling 220 kVA as an auto transformer. Okay, so only 20 kVA in two-winding transformer can be capable if you reconnect as an auto transformer up to 220 kVA. Out of 220 kVA, 20 kVA transformed by the transformer action and remaining 200 kVA transformed by the conduction method. Okay, that means directly conduction method. So note here, that means how a 20 kVA a 20 kVA two winding transformer is capable of handling, is capable of handling 220 kVA as an auto transformer, 220 kVA as an auto transformer. Out of 220 kVA, we already seen here, out of 220 kVA, 120 kVA, only 20 kVA, only 20 kVA 20 kVA is transformed from primary to secondary, is transformed from primary to secondary by transformer action, okay, and the remaining 200 kVA is directly conduction method, open to load, from source to load by direct conduction method. Okay, so just we stop here, and in the next session we will discuss from this point.